Throughout the ages, man has always known one thing. Rockets are awesome.
We have liftoff. We have liftoff at 7 a.m. Eastern Standard Time.
I wouldn't touch that if I were you.
Today we're going to take that a step further with science and theoretical stuff. And I'm going to hand that off to Isaac now. Isaac?
Thanks, Alex. So, today, we will be talking about rockets and the science behind them. What we will be doing is we will have a rocket that we will launch straight into the air, and then through that we will calculate the time that the motors burn, the time it takes for the rocket to reach apogee, and the time it takes for the rocket to fall. Then what we will do is we will attempt to break an NFL record of longest field goals. We will be going for the 120-yard full field kick. And we will aim it at 30 degrees, which provides the farthest distance with air resistance. And we will see how it goes.
Alright, so this is trial number 1. We're going to launch the rocket, and we're going to try to calculate the velocity using the time it takes for it to do its full arc and then come down and land. And then also we're going to measure the delta X on how far it goes down the field when we launch it. So.
And that is the rocket. What kind of motors are we using?
We're using a C65 in the rocket. 3, 2, 1. That one. Oh, that's going straight down. Alright, well, trial 1 has gone a little unexpectedly. Well, yeah, there was a problem.
That's where we launched over there.
And you can see that gravity took pulled quite strongly. The acceleration is very strong as it drove the rocket 2 inches-ish into the ground. So what we're going to do later is calculate how high it fell based on how long it took to fall.
Also, the rocket may or may not have exploded when it was up there. So we're just gonna get that.
Wait, we need to measure how far it went.
Well, yeah.
Alright, so here we are at trial 2. Trial 1 didn't go quite as well as we expected, so we're doing a second trial for you guys to help you with your physics and rockets. So we'll launch.
Hopefully this one does not explode. 3, 2, 1.
Okay. There it exploded. Oh god.
Oh god, it's going right at me.
Where is it?
There's a bee.
We can actually measure the distance now without a fence being in the way. So.
Alright, so we'll be back with the results.
Alright, we just measured it from the distance from where it launched to where it landed. Using significant digits, it came out to 164 feet.
Alright, so in trial 2, we found that the rocket accelerated with the thrusters going for 2.11 seconds. Then the motors went out, and it coasted for 3.22 seconds until it reached the peak. And then there to the ground, it took 18.95 seconds to make up all that time back. So what we want to find right off the bat is how much distance this is right here out of the 164 for the time. So what we do is we do 3.22 plus 2.11 over the total time, which is 24.28, and then we want to multiply that by 164. so we can find out what fraction of that is going in the upward direction. And the answer to that is 36.0 feet. And so using that, we can find the average velocity as we go up using the range formula. So if we type in or write in 36 equals v naught squared minus sine of 180 degrees, because we fired it in a straight up direction, we have to multiply by 2, all over 32.0 feet per second squared. And so what you do is sine of 180 is just 0 on the unit circle, and then so you get v naught over 32 feet per second. So you just multiply 32 by 36, and you take the square root of that because v naught is squared. So 36 times 32 square root, and that you get 33.9 feet per second. And that's the acceleration. And then if you, to figure out the height here, you just put in these two together, which is 5.33 seconds times 33.9 feet per second, and you get 100, let me check my notes, what did we get?
181.
181 feet. And there you go.
As Alex said, we have a parabola for the rocket's flight with 5.33 seconds for it to reach its max height, and also we have 164 feet for the delta x, and as Alex found, this is 36.0 feet, leaving the delta x for the falling to be 128 feet, and this is 181, which is actually irrelevant for what I'm about to find. What I'm going to find is the average velocity, or the wind velocity, for when the rocket was falling. So in essence, Vx, which will be the delta x over the delta t, which is 128 feet over 18.95 seconds. So the wind speed is 6.75 feet per second.
Alright, we're about to beat the 100-yard NFL field goal record.
Here we are.
Except with a rocket.
Here we are with 120 yards to go to 3 points. Here we are, 30 degrees, and let's go.
Theoretically, this should work. Instead of the gap.
Watch your distance.
Oh god.
Alright. 3, 2, 1.
Oh! It's good!
I don't think it was.
Good!
Yes! It's good. It made it through when it got to that point. Oh yeah.
There
Alright.
we go.
That-
Let's go look at it.
Robotics, physics,